What is up, Math Made Easy fans? Today we have a banger. Of course, I mean, is there ever a day when we don't have a banger? Like, really, guys. Welcome to this episode of Math Made Easy. Today we got another AMC 12A problem. This, I believe, is number 9er. So, a little bit easier than the 13 and 5 that we've seen on Sunday and Tuesday, but still not a walk in the park by any means. Nothing on the AMC 12 is. But without further ado, let's solve this hard problem easily, and then I'll go into the proof of it later. A sequence of numbers is defined recursively by A1 equals A1 equals A sub 1 equals 1, comma, that's a comma, sorry. A sub 2 equals 3/7, and A sub n equals A sub n minus 2 times A sub n minus 1, all divided by 2A sub n minus 2 minus A sub n minus 1, okay? Epic. So, and that is for all n's greater than 3, or equal to 3. Then A sub 2019, because it's 2019, you know, can be written as P over Q, with P and Q being relatively prime positive integers. What is P plus Q? Okay. And then they give us 5 possibilities, but we're not going to worry about those for now. What we are going to worry about, though, is finding a pattern in this, because you know, we're not going to grind all of these all the way up to 2019. You know, that would take days. But let's just solve for A sub 3. So that would be 1 times 3/7. So 3/7 on the top, divided by, 2 times 1. So 3/7 over 2 minus 3/7, so over 11/7. So this 7 is going to cancel out, so we get 3 over 11. A over 2 is 3 over 7. A sub 1 is 1, which is the same as 3 over 3. 3, 7, 11. If you were to do A sub 4, you would indeed get 3 over 15. So here's a problem. So here is a very epic pattern that we found, and we can be pretty sure that it exists. And doing the AMC, if you were doing the AMC here, you would say, okay, you'd be satisfied there. You would say, well, we have 3 over, it looks like, well, 4n minus 1, right? Because 11 is 4 times 3 minus 1. 7 is 4 times 2 minus 1. So you just say, okay. So we would have 3 over 2019 times 4, which is 8,076 minus 1, and that would, of course, you would add that up and you would get the answer, which is 8,078. Epic. That's our answer. But now I want to show you guys how I would prove this whole thing to be true. Here is the eraser. We're going to keep that solution on there. So, I want to prove how this can be represented as 3 over 4n minus 1. Now, if I prove that by mathematical induction, which is what we're going to do here. That means that 1 less than this is just going to be 3. So this is a sub n. This would be a sub n minus 1. 3 over 4 n minus 5. Now what we got to prove is that if we go 1 more from this, it's going to be over 4n plus 3. Oi, oi, oi. Well, let's plug it in up on the top. So we have 3 over 4n minus 1 times 3 over 4n minus 5. Okay? And this is all over. Well, 2 times the 3. Wait a second. No, sorry about this, guys. Just for your convenience, I'll actually switch these out. Sorry. I mean, you could do it the other way, but it just looks better when we do it this way. 3 over 4n minus 5. And then we see this minus 3 over 4n minus 1. Okay? Now we're going to have to also multiply is we're going to want to cancel these denominators out. So we'll multiply it by 4n minus 5 and 4n minus 1. We're going to put those on both the top and the bottom. So we're really essentially doing nothing, but we're making it, by making it a little bit longer here, which is kind of counterintuitive, we're actually making it a lot easier for ourselves. So this just completely cancels. You can see that completely cancels, and I'll erase this and I'll put it up there so you guys know what the answer is. This completely cancels and it makes 9. All over, well, this thing. When we multiply this group with this, we get, well, the 4n minus 5 cancels with this 4n minus 5. So we get 2 times 3 times 4n minus 1. 2 times 3 times 4n minus 1, that's 6 times 4n minus 1, which is going to be 24n minus 6. Okay? And minus this 3 times 4n minus 1, we're going to do the same thing. And we're going to get minus 3 times 4n minus 5, which is going to be minus 12. And we have a minus, but you know we gotta multiply a negative, and a negative makes a positive, so plus a good old 15er here. Simplify this to 9 divided by, well, this negative 6 plus the 15. 24 minus the 12 is going to be 12n plus 9. If you divide all of this stuff by 3, divide top and bottom by 3, you get 3 over 4n plus 3, which indeed is what we would expect if we were keeping going for a sub n plus 1. So that's the proof by induction, and this is the answer to the problem. Now, you wouldn't do the proof by induction in the actual AMC, but I think it's very useful to show you guys exactly how this works. So without further ado, my name is Math Made Easy. Make sure to tune in tomorrow. And have a nice day.